Hello programmers, time for some processing. Look at your program again. We've declared our structure, created our structure, declared our variables, got our input. Now we actually have to do the math. The math on this one's straightforward. We need to use our scaling factor in our calculations. In almost all cases, literals should be redefined as constants, almost always. And then we're going to take another side trip. We're going to look at math. There's a lot that we need to do in math. There's a lot that you're going to be doing in the next few programs. So again, that's a side trip that I think that's really, really important. So let's add this step. And so let's do processing. Again, it's an assignment statement. So our assignment is dog's age equals human year. Now we could just do times 7. That kind of makes sense right there. Dog's age equals human year times 7. But this right here is called a literal. And it is what it is. And normally in cases when you see something like that, that's bad. If we use 7 all throughout our program, and then we had to change it, we would have to go through and change it everywhere we looked. For example, if the tax rate is 8.2% and you hard code 8.2%, 700 different places in your program, if the government changes the tax rate, you're going to have to change it in all those different locations. But if you use a named constant, then you simply use that instead. You have to change it one time and life is good. So this is scaling factor. Okay? And again, let's test. You said human years plus which, let's not do that, which is plus dog's age. And we can test this and see it works. We always want to test. So let's run this. What is it? So if I do 2, I should get 14. I did. And if I run it again and I do 5, I should get 35 and life's good. Okay? So there's another side trip that comes after this. And the side trip is for the math that goes through next. But I think what I'm going to do here is I'm going to include processing because this is a really, really short video. So there's the math, we'll use that for our logic, we'll come back to that. So our output on the program is also very straightforward. The important part of the processing was to get to the point where we would have something to output. There will be a side trip after this for using printf and for using some of the techniques. But to complete this one, let's make it pretty straightforward. So are we good with this? We are. We're not doing any ifs. We haven't learned this yet. So do we have the output like that? Maybe. So I think what I'm going to say is if your dog is plus human years plus, now I always have to do plus, space old in. Now I don't want to go past the red line of death. Do not go past the red line of death. So I'll hit enter. It does it for me automatically. In human years, then it is plus dog's age plus, old in dog years. And we'll test to see if this looks right. You got to be careful and put your spaces in here. So did I do, it's got a red right there. What did I do wrong? There's human years, and it should match. Like on here when it says dog's age, if I click that, you'll notice that dog's age shows up. I have a red line here. I could put this over here and say, wait a minute, something's missing. So what is it? Well, I spelled it differently. So if I delete that, now you'll notice that they all show up. So let's test that. We found our error, we fixed it. Let's go through that. So let's put this right here and let's do 5, and we say if your dog is 5 old, okay, that doesn't make sense. Let's put years. In human years, then it is blank years old in dog years. Let's try that. So if I run that, let's do what I do last time. I don't remember. We'll do 5. If your dog is 5 years old in human years, then it is 35 years old in dog years, other than having the closing period. Now I'm done. So what I've done is I have completed a complete program, and it's all pretty much good to go. I think that I should have documented, so let's see. This is dog's age in human years. Oops. And this is dog's age in dog years. And I'm kind of OCD sometimes, so I'll go ahead and make these line up. So this is my completed program. Let's see, I've got documentation, I followed all the standards, I described it, there's my main, I've got variables, I define my variables, I've got my input, I've got my processing, and I've got my output. And then I look for any kind of wasted space where it won't make it clear. And I think that I'm done here. And so I would go through a code review to make sure that this is consistent, turn it in for my grade, and hopefully it'll do pretty good. Make sure you follow the indentation rules and all that good stuff. Remember, there's two sides after this. There's one for doing math, which is really important, and there's one for doing output and some tricks there. And then there's going to be one more video that follows this one on debugging, and just kind of an introduction to debugging, and that one's kind of fun. So let's close this one out and we'll look at the next one.